Brianna. Oh, hi, this is Mitzi and Brianna. I think it's just starting to record. We are on lesson 5, normal distribution. We actually didn't meet for lesson 4. Did you get the homework for lesson 4 pretty good?
Yeah, I did the quiz and everything, but I haven't looked at the homework yet. I've been kind of behind with work and everything, so I'm gonna do that tonight.
No, I'm with you. Actually, I did the preparation one. That was actually pretty good.
Yeah, so we'll see how the homework does.
Yeah. So now lesson 5, normal distribution. I'm struggling, and I thought I got it in my reading, but now I don't. So do you want to just kind of go through this together? Maybe we can make sure, because my answers are not coming out the way I thought that they should.
Okay.
So the first question is, classify each of the following batting averages as either unusual or not usual. Unusual. Use the z-score to make the determinations.
Yeah.
So let's see here. So when you copy and paste in your batting average into that quantitative descriptive status Excel.
Oh, you can plug it like that?
Well, that's how I was able to get the mean.
Okay, because I knew you needed to get all those, but I didn't know if you just I didn't.
Well, that's because I was looking for how we could get the mean and the standard deviation. I'm wondering if I'm doing it right.
Yeah.
Oh, wait a minute. Maybe I'm doing it wrong. Okay, well, maybe we should do it by hand. So it's 0.19, right, is the batting average.
Yeah.
And we would subtract that, the mean.
Yeah, but we don't have the mean.
Well, that's how I got the mean. I plugged it all in, and it gave me the mean of 0.2611 or 12.
Okay.
So I'm wondering if that's where I went off. And then the standard deviation was 0.0339. So if I do that, 0.19 minus 0.2612, that equals a negative 0.0712.
But the solutions say negative 2.088.
Well, we have to divide that by our standard deviation, which is 0.0339.
Is that how you got it then?
And then what I get is a negative 2.100, and that's different from the solution. It's close.
Yeah. It is. Okay, so you have the negative 0.19 and you have to subtract it by the mean and divide by standard deviation. But how did you get those? I'm just so lost right now.
Okay, so what I did was I went to the batting average spreadsheet.
Okay, that's probably one.
Yeah, and I pulled that up, and I copied and I pasted the column. Let me know when you got it up.
Okay.
Yeah. Let me see if I can share my screen too. So I pulled up this one here. Do you see my screen?
No, I don't.
Maybe I should say start share my screen, and then you can, there we go, share. Here we go. Okay. Can you see my screen?
Yeah.
So I pulled up this spreadsheet and I copied this batting average.
Okay.
And then I pasted it into the quantitative description area here.
Okay.
And this is how you get your histogram, right? So you can see that it is a bell-shaped histogram.
Can't see it. It's like there's something covering it, I think, or
Oh, you can't see that? Can you see it now?
I just see like you opened up your Excel, I think. Oh wait, that might be me. No, it's not.
Oh, okay. Let me see. How do I?
Oh, that is me. Never mind. Watch. Okay, now I can see it. I can see it. Here's my
Okay.
fault.
Okay. All right. So I copied that information into this this spreadsheet here, quantitative descriptive status.
Oh, so you took it from one and put it in the other.
Yeah. So then I pasted it here, and then so my mean is right here. Can you see right here?
Yeah.
0.611, and the standard deviation comes out to that.
When you're doing the math, do you round up or do you just leave it as that full number?
Maybe that's why it's wrong. Maybe we should round up because I was just rounding up to.
Yeah, I don't think you round up until you get your final calculation. So I think you should just leave it as that. So
Okay.
0.19 minus 0.26118834.
Mm-hmm.
No, that's my calculator.
So if I actually, let's do it on the side here. So 0.19. Let's do this.
Oh yeah, I guess you can do it on Excel. That's easier than writing it out.
Yeah, minus this mean here will equal that, and then we'll take that.
Hi, Eric.
Hi, Mariela. We're trying to figure out the homework stuff.
Yeah.
Okay, so negative point. How'd you do, Mariela?
Yeah, I did it. The number assignment number 4. Yes.
No. We're on 5 right now. How did 4 go for you?
Sorry.
You finished 4. You said.
Yes, I finished 4 and I finished 5 also.
Okay.
But I don't understand in the number 5.
So
the first question.
That's what we're going over now.
Let's going over the first question right now. So I'm just showing Brianna how I got my answers for the first question. And you know what, Brianna? They're kind of close. So Mariela, what we did for number 1 was we opened up, and I'm showing my my screen here.
Yeah, your Excel. I'm looking your Excel.
Yeah, we open up this Excel, the batting average Excel. And then we copy the batting average here, and we put it here on the quantitative descriptive status Excel.
Okay.
And then this is our mean.
Yeah, so I was looking because it says you have to read the reading assignment, no? And I was looking to the lesson 5, where it's explanation, and at first you have something about batting average, and I was looking for that data, and not for the Excel data that we.
Yeah,
I to figure out how they get the answers.
I did the same. I came back here and I was looking for the numbers, and then I remembered as I was reading here, right there, it says batting average data. So, well, let's go there. It's faster. So that's I went to that one, and I just grabbed it from there and stuff. So it makes it a little easier. The numbers aren't exactly the same. So in this, it's for the 19, it's a negative 2.09. And I think the answer is negative 2.08. But I think that's, you round that up, and that's going to be a 9.
Yeah, I think.
So I think we're okay there. Oops. So our first one. So let's just say our first answer is
unusual.
I'm going to copy that and then put it in here. So this one is our z-score is e equals 2.0.
And then from there, you can just change your numbers from the first calculation to.
Yeah, so this is the negative 2.09. And then same thing for these. So 2.225.
All my numbers are off because I have it plugged in now like yours, and it doesn't. It's not like the solution.
Wait, I'm gonna stop sharing my screen. Show us your screen.
Okay, hold on. Let me pop up on my screens. There's so many. I really need to get another thing.
I'm the same way.
I'm looking for the Excel. Okay, just to.
Okay. That's not the thing. So I just plugged in. Can you see my screen?
Yeah.
Okay. And then I'll pull this. That's like the answer thing. So I put in 2.225 right here, you know? And because so then it will subtract by the mean and divide by the standard deviation. And that's still not the same. It's like 0.10 off.
Yeah, but it's close. So let's see here. I'm gonna pull mine up again. So
oh, look, it says please note that the steps show rounded numbers, but that the final answers to the problems are calculated without rounding. So
where did you see that again?
Like at the top of the solutions. Right here. I have it pulled up. So 0.225 subtracted by 0.26 and then equals, should I round that? Or
well, I didn't round it. I just kind of went through and I'm
just seeing if I can get the same answers.
Yeah, I know. I don't think we're gonna get the same answer.
No, I don't think so.
So yeah, actually, if we just take what I'm getting is 0.225. One is gonna come out to negative 1.067133, something like that. Is that what you have?
Huh?
Maybe a negative.
I got negative 1.067.
That's what I have.
Okay.
Yeah.
And then whatever the next 0.32.
Yeah. Mariela, do you see how we're getting it?
Yes, I'm looking at. I'm trying to download again. I don't know where I saved the file.
Oh,
but I downloaded the Excel, but I understand how are you doing. Yes.
Okay.
And then if you plugged in the next one, you got 1.8817, so that's really close.
Yeah.
But now, how do you distinguish if they're usual or unusual? Is there like in the...
It has to be more than 2?
So yeah, the
Okay.
and if it's less than 2, the way that it described it in here is if it's less than 2, then it's usual, not unusual. And then if it's more than 2, then
More
it's
than 2.
usual.
The absolute value, no? The absolute value.
Yeah.
It could be negative or positive, but more than 2.
Right. So that's why on 0.19 is unusual because you come out with a negative 2.1 basically if you round that off. B 0.225 is not unusual because your answer is less than 2. And 0.325 not unusual, and then 0.335 I have as unusual.
Yeah. Okay, well, I get that part now. We got past that part.
Okay. Should we move on to question 2?
Yes.
Okay. Find the probability that a randomly selected professional baseball player will have a batting average that's greater than 335. So we know that the probability, let's see here, batting average, it's great. I was just trying to figure this one out too. Could anybody figure this one out?
Losing everything.
Trying to look back at my notes on the probability of it.
Yeah.
Yeah, more than 335.
Okay, So I saw in here, where is it? Okay, so normal probability. So we know that our z-score of 335 is 2.176, right? So I think we put in, you remember the applet?
The applet, yes.
Yeah.
Because then, yeah, you see like converting a z-score to probability.
Yeah. So if you put in the z-score 2.176, I get a 0.9852.
I put in C number 335. What number I put on C?
2176, your z-score. So when
1 point.
Yeah. Which I have is 2.176. Is that what you folks have?
Yeah, I just plugged in. I still had another number. I still had C plugged into mine. That's why I was reading one.
Okay.
0.8. I don't. I will show my
Your screen?
screen. Yeah.
Okay.
Yeah. Just you help me here.
Okay.
How? Could you see?
Well, the z-score for 335 is 2.176. So that's what.
Yeah. Where? Could you see my screen?
Yeah.
Yeah.
Yeah. On area, what I have to put. What? Here. This is the applet.
Look,
Yes.
see down at the bottom of the bell. So your bell is like this, but right at the bottom, right down there, see where it says where you have 2.8. If you change that to 2.176.
2.17.
No, down at the bottom of the bell. Abajo the curve.
Yeah.
Yeah, down there. Yeah.
2.8 I put.
Or 2.176. Actually, you can. That's going to be a negative 2.176. Yeah.
And here also. Yeah.
It's going to change it. So.
And then you get your area.
But then your probability is the middle, right? Let me see. This is where I'm getting kind of confused because when the normal probability applet is, because the blues you can change them, and if you get to the middle, it's 0.9704.
721.
But then let's see, the probability the random sector baseball player will, let's see, find the probability the random sector will have a batting average that is greater. So it's going to be greater than 3.335.
Could you show me your screen?
Wait, I'm still trying to figure it out. Hold on, let me see.
Oh, yeah, I don't know what I did.
Okay, I think I got it. So here, I'll show you my screen. Okay, so on my screen, if I take the z-score is 2176, right?
Yes.
And so I put the z-score in there, and we're looking for the batting average that's greater than. So your batting average is 0.335. So you're going to go to the greater than z-score, and then I get a 0.148.
Ah, okay.
Oh, so you just clicked over there.
Yeah, I just put it in here. So.
Oh, because I had. Oh, because each side's a different probability.
Different, yeah.
You just click the right side and you get about 14%.
Right. Actually, if we round it up, it's.
Or 0.015. Yeah.
Yeah.
Okay.
But is this the right answer? Yeah.
Yeah.
It is.
Yeah.
Okay.
Question. Yeah, I understand how you get the area. Yeah. How you get the percentage. But I don't know exactly how you get the number 2.176.
Oh, okay. Let me show you. So I'm going to go back to the screen here.
Mm-hmm.
So after we copy all of this data and we
Yeah.
put it here, then we have our mean here and our standard deviation here. So I kind of just made a formula here. So right here is 0.335 minus our mean, which is here. So this is my F21, right? F21. So minus the mean, and then is 0.0738. Then I took the mean, this one here, and I divided it by the standard deviation, and that's where I got 2.176. So let me write it out. Okay, Mariela? So
Okay.
if I equals 3.335 minus
the mean. No?
Yeah, let's just do 2617.
Uh-huh.
If I do that, then
you get that number. Okay.
It's about, right? Then I would take this number here equals 0.0733, and I would divide it by my standard deviation, which is this number here, 0.0339. And that goes to
yeah, okay.
But because I just did it straight, it's I didn't round it up on this one to show you. I kind of rounded it up. So this is the same thing. I just
yeah, I got it.
Got it. Okay.
Yeah, thank you.
So that's where I get it from. Sure. Okay. All right. So back to this one. All right. So do you want to go to 3? Let's see. Who wants to do? Anybody have a chance to do 3? Let me stop sharing my screen.
What's 3? Oh, it just talks about what a normal.
Yeah, about the concept theory.
Well, we just saw what it looked like. It's just like the bell shape. It's symmetrical, and you put the z-scores on each side.
Mm-hmm.
And then,
so I have here. I wrote in my I wrote down symmetric has a bell shape. Normal distribution. So yeah, it's just that it's a symmetric and it has that bell shape.
Yeah.
Like, all right there.
And we just plugged in the z-score, and you found the probabilities.
Yeah. Okay. So, in the following, who wants the other one? Okay, the following, number 4, formula. Please state which symbol stands for what each symbol. Oh, that's easy, right?
Yeah.
Yeah. The X is the, how do you say, la muestra, the value?
Yes. Yeah. The value or the data, right?
Mm-hmm.
I like that U thingy. That's the mean.
The mean, yes.
0. So what does what does the Z stand for?
That's just the Z point. The we calculated.
Sorry, I don't understand.
The Z, Zeta.
Yeah, score.
Mm-hmm. What does that mean? The if we were to write it out, I think up here it says
yeah, theta means how far you are from the deviation.
Yeah. How many? This here z-score for data tells how many standard deviations away from the mean the observation lies. So, yeah, how far from the data? Okay. Number 5.
Oh, the 3.
The 68. So no less than 3 sentences. Please define and describe 68, 95, 99.7 rule. Okay.
Well, if you look at the bell shape or whatever, so like the first, you know, where you have your Z shape, your Z line. 68% will lie in that first between that, right? Is that
right? That's correct.
And the standard deviation is within 1, no? You don't have more deviation than 1.
Right. Lies within 1 standard deviation of the mean.
Mm-hmm.
Yeah.
Yes.
And 95 lies between the 2 standard deviations. And then 98.
Yeah. 9.7 lies in 9.
Yeah. That's a cool. Okay. All right. So, okay, now we get into more calculations.
Yeah.
Yes, we do.
Okay, the mean of all quantitative scores on the GRE is 150.8 with the standard deviation of 8.8. Scores on the quantitative portion of the GRE are approximately normally distributed with mean.
Well, with that, you just plug in what the data on the table, 150.8 and 8.8. At first, when I looked at that, I thought it was like you had to do this big calculation, but it gives you all the answers right there.
Right, right. Because the mean is 150.8.
0.8.
Standard
Deviation
is 8.8.
8.8.
Okay. What portion of the people who take the quantitative portion of GRE will score above 165?
Mm.
So we have to find the Z-score, I'm guessing then. So
yeah,
165 minus 150.8.
Mm-hmm. Equals
equals 14.2 divided by 8.8. So I got 1.6136. But then do you plug that into the applet?
should, yeah. So
yes, no, we can use
you're like way ahead of me, divided by.
Yeah, I did go really fast on that.
Now I know. Now you're like super whiz. Let's see here. You got the Z-score of 161.
Yeah.
Okay. And then let's go back to our applet. What do you get on that one?
0.0533.
Yeah, because it's above, right?
Yeah.
Okay. Yeah, that's what I did. Mariella, is that what you have too?
Yes. I'm checking with the applet because I didn't use it.
Good applet. I like that applet.
That is nice.
Oh, it's good, huh?
Mm-hmm.
Yes.
Okay. And then it's like if the student score is 10th percentile, what would the corresponding Z-score be? 10th percentile.
Oh, so then you could plug that. I know that the distributive thing gives us percentiles, but I don't know if you could, because I don't know how else to figure that out.
Okay, let's see. Yeah, the 10th percentile.
10%. We can see the applet maybe using that.
First 10th percentile, what would their corresponding Z-score be? Because the 10th percentile would make them 90%, right?
What is their
Is that right? If they're in the 10th percentile, does that make it the area 90%? Or am I wrong?
But the 10th percentile would be the lowest?
So
The highest?
0.1 then?
I have no clue.
Okay, because if you go to the z-score would be 10 percentile. Okay, let me go back. I'm like this. I keep getting mixed up with the percentiles and everything. Hold on. Let's see here. Because I think we can say, okay, all right, here we go. Oh, second percentile using normal distribution. Now, for example, 25th percentile is a number of the data set that's greater than or equal to 25% of all values in the data set. So we know that 10 percentile will be 10%, right?
Yeah.
Okay. So find the z-score. For that, for x. Oh, okay. So, okay. This is where we go through our algebra equation. My other paper here. The z-score corresponds to 90. Okay, I'm a little confused. Are you guys seeing the 3.4 in the lesson, calculate percentiles using a normal distribution?
Oh, yes, I do see that.
Okay.
So,
oh, so we would just put in 0.1. Is that would be the 10th percentile in the normal probability applet?
Yeah.
Give us our z-score. So if we did 0.1.
0.1?
Oh, no.
I got 0 area.
His 10% is 0.1, right?
Yeah.
0.1. Oh, it's not giving me anything. I think it's it looks like it's 1.28, but let me see. Nine percent to the left. Okay.
Standard deviation.
well,
Okay. So we know that z, let's see, z.
Esto es 8.3.
So we know that our 90th percentile z.
well, they just plug.
Are you able to plug in 10%? Because it only gives the 90th, right?
But we know that the standard deviation is 8.8.
Mm-hmm.
The highest grade is going to be multiplied by 3 because I think that the 10% is the people who has the greatest grades. So I think that we have to multiply 8.8 by 3. Yes. No.
Where does 3 come from? 0.3 come from?
For the concept, we have about standard deviation.
Okay, that's 8.8, right?
Mm-hmm.
And then
we have 150. 0.8.
Um, okay, let me go back to this. Let me just write this in. So you said, the z-score. Wait a minute. Let's just figure out the z-score off of what we have now. Oh, we don't have the x then on this. We have the mean and we have the standard deviation. So we have to solve for x first, don't we? To be able to understand the 10th percentile.
Mm-hmm.
So we don't even have the z-score.
Okay, so the answer, so I'm looking at the solution as negative 1.2816, you know?
Okay, let me see.
And it popped up on my normal, I'll share my screen. Okay. So then I went to the applet and I just put 0.1 in here to put like, because I just want the 0.10, you know?
Yeah, see, I couldn't do that. I was trying to figure it out.
Just put it on the area.
Right there. Oh. I just put 0.1 in there and then that's how I got it.
Oh, yes.
I'm trying to figure that out.
I don't know if we're just thinking too much into this and it's not, you know, like.
No, that's the right way to do it, but I just couldn't do it. So
Just using the applet. You put 0.9 on the area and you got the percentile highest.
1.282.
Yeah, and that's what the solution page says, so.
That's what we're going with then.
Yeah.
1.2. No, I was trying to type it in 0.1 and I couldn't get it to go.
Because it is under 2, then it would be not usual. Or that's what the solution says or whatever. Like, I'm just trying to make sense of all that still. So.
Okay. So you did 0.1. There it goes. Okay, yeah, that's it. So it's a negative. Okay.
Yeah.
Okay, awesome. Thank you.
Thank you.
Well, I think we were thinking way too hard, and then I was like, why are we not getting this?
I know. Okay. Good job.
What is a quantitative GRE score for a student who's score? Okay, so now we have to use that number. But I know. What? I don't know.
The quantitative GRE score for. Okay.
So do we use, okay, so then we'll just use that z-score that we just got and plug it in, right?
Yeah. So that we can, because now we're trying to solve for x.
Yeah, so negative 1.2816 minus the mean.
So
is that right?
The mean is 1, so it's actually 1.282 equals x, which is our quantitative number, minus 150.8 divided by 8.8, right?
Yeah, but I don't think that's right because I didn't get it right.
Oh, you went through that already?
Yeah, I think I went through it right. I don't know if I did or not. So maybe.
Let me see. This is 8.8. I'm just going to run through it quickly.
Okay.
Then
I got like some negative number, and I don't think that, like negative 70 or I don't know if I just plugged it in wrong or whatnot.
So plus 150. 150. Okay. so 1.282 times, that's a negative 1.282, right?
Yeah.
Okay. Minus 150. Okay, so that's 130. What did you get?
Negative 70 or something, but it's not. I don't know if I did it right.
Let's see.
Where
Where's
is-
our
You
answer?
did it.
Okay, so okay, I got it.
Okay.
Take I'm just gonna walk through it. So if you go to the lesson and see where the calculation is under 3.4.
Yeah.
So ours, it's the same thing. It's the negative, z-score is negative 1.282. And then our x equals x minus 150.8 over 8.8, right?
Yeah.
Okay. So then we go through the math and we do the next line is 8.8 multiplies 150.8. So that cancels it out, right? Cancels out that 8 and the one at the bottom, the 8.8. So we have to carry it over to the other side, and it'll be 8.8 multiplied by negative 1.282. So if you multiply that 8.8 times 1.282, we know it's going to be a negative number. It's going
Yeah.
to negative 11.28.
0.28. Yes.
Right. Equals so that equals x minus 150.8. So now we have to add 1.50.8 on each side, and that'll cancel it out on your right. But if you add it onto your left, then that comes out to 150.8. It comes out to 139.5.
Yes.
Which is what you need.
And that's the answer. Woohoo!
Yeah.
I'm so smart all of a sudden.
I got the number, but I have a question because it says the GRE score for a student who scores at 10%. No, 10% is the highest grade, the lowest grade in this.
So 10% is what we did was we took our z-score, the 10 percentile, which gave us the negative 1.82 when we put it into that.
Yeah, no, but I am trying to say that the 10% deal means that the student has the lowest grade. Yes,
Yes.
because it's less than the mean.
Yes. Yes. Because they scored only higher than 10% of the whole class.
Okay.
Yeah. Yeah. So then we round it up and then it's 140.
Because I was thinking that the result must be more than 150 because I was thinking 10%, but for the highest. No, it's going to be 90 in that case, no?
Right. But whenever they say percentile, that means that they score. That's the highest it'll go. So 10% means that they scored higher than 10% of all the class. So if it's 90 percentile, then they scored at 90% or higher than everybody else in the class.
Mm-hmm.
Okay. So the next of this one should be easy then, right? Number 7. Yeah. Okay. The mean speed of hydrogen at room temperature is 1,800.
1,800.
With a standard deviation of 600.
100, yes.
At room temperature, the mean speed of hydrogen particles is approximately normal with the population mean of U meters per second, standard deviation of. So that's the same, right? It's right there, 1,800. is our mean.
Yeah, and then 600.
Sorry, say that again. Oh, I'm sorry. The mean is 1800, right? And the standard deviation is 600?
Yeah.
Okay. Okay. What is the probability that the particle has speed over 500?
So we just plug that into our z-score. So 2500 minus 1800 divided by 600.
By 600. It's 1.167. When rounded, 1.17.
Sounds good. One point 1.17, and then we plug it into our applet, right?
Yeah.
Yeah, and then we can get 1.1217.
So wait a minute. This is where I always get a problem. This applet drives me crazy. So 1.17 is our z-score, right?
Yeah.
Okay. All right. Now. Yeah. So
and then you just click the one area.
It's going to be to the right.
Yeah.
Because it's over the mean. So it's 0.1210. Is that what you have?
Yeah, 1200. 12?
Yeah.
1210.
0.1210?
Yeah.
Okay. What is probability?
12%.
Less than 25. So
then you just click the other parts of the applet.
Yeah.
So 2 parts of the applet.
0.8790?
Yep.
Okay. What is probably the randomly selected particle at speed the less than? So that would be 0.1210, huh? Oh no. The same thing. But I guess that's right, huh?
For what?
The number letter D.
Okay, so then wouldn't you just plug it into your equation again? Yeah, so 1500 minus 1800 divided by 600 to get your z-score.
Oh, gosh. Yeah, you're right.
0.5.
Minus 1800.
And then you plug that into your z in your applet.
It's 30%. 30.
Yep, 0.3085.
Yep.
Yep.
0.85. And what is probability a randomly selected particle has speed that is between 15 and 25? So that's going to be 0.6915. Is that what you got?
Yeah. You have to minus rest.
That's what the answer says. Oh, shoots. I didn't get that right. Let me go back to that. I have 0.6915, but the answer is different.
Different. I got 10% minus 0.66 I got.
Yeah, let's see. Probably the randomly selected part speed that is between wait.
But we use the applet. 0.5.
Here it should be 0.3829, right? If it's between. Minus equals less than. Oh. Minus.
You just subtract C and D from each other.
Yeah, I just got that. I just figured that one out.
Yep.
Okay, that's right. So we have to take the less than 2,500 and less than 1,500, subtract that from each other. Okay. And I have 0.57.
1.7. You're going to put 1.17.
I know. If you take the answer for number C,
yeah,
and subtract the answer in D,
mm-hmm.
then you get 0.57. Okay, that F, holy cow. The third quartile is 75%, right?
Yeah, 75%. Yes. We use the applet there.
So
$12.51.
So the third.
Yeah, sorry. The score is 1.15. Mm-hmm.
Okay. 5 is going to be 1.150. Is that what you're saying, Mariella? For the z-score. So 1.150 equals x minus
2,490.
Oh, you figured it out already?
I think just. Oh no, it's not the number. Because I read the answer, it's another answer.
100 times 1. Oh. Let's see, 600 times 1.
Mm-hmm.
Okay, and then 2490, is that what the answer is?
No.
Oh no. Okay, so I got the wrong standard deviation. So the third quartile of speeds of hydrogen. So it's not 75% then, huh? Would you 25, 50? It should be 75%, right?
I got it.
You got it?
Yeah. If you use the applet, we put the area the 25.
Okay.
The highest. When I put I will share my screen. When I put here the 25, I got the CT scores. It's 0.674.
Okay.
You see the score? Yeah, and this number I must multiply by the deviation, the standard deviation that it's 600. Yeah, I multiplied 600 by the CT score 0.674, and I got the deviation is going to be 404.4. I have to add this to the mean, and I got what is going to be what is the fair quartile of the speeds. It's 2,204.
2,204.4. Okay. So going back to your can I see your
the applet?
Yeah, the applet. So you put in 25%, right?
25%, yes.
Okay, that makes sense. Okay. Did you get that, Brianna? Because I was doing 75%, but that wasn't right.
Yeah, you had to do 25%.
Yeah. Okay. Good job, Mariela.
Something like today.
Okay. What? The QQ pots? Oh, we got to look at the QQ pots. Are normally distributed or not? Record your answer if you justify your answer. I think
these are pretty easy. I don't know about you guys. Like,
yeah, this is not normal. Plot B is not normal. Plot C is normal.
Plot C is normal because they don't follow the diagonal line, right?
Yeah.
Yes. E then will be normal. Oh, part E is, I'm sorry, part D is normal.
Normal, yes.
Is not normal. F is normal. Okay, got it. All right.
D is not normal because we have points so far aligned, yes?
Yeah.
There are few, but there are.
Yeah. Okay. We need to take our quiz, huh?
Yes.
Okay.
No.
All right.
All right. Okay. Check mark. Okay. And let's go ahead and start our quiz. Oh, please don't be difficult. We're like already at an hour here. Our TA is going to love this. Okay. All right. True on the first one, of course, we all met. And the second one, another true. Okay.
Yeah.
Okay. The total area under a normal distribution curve must equal 1, right?
Right.
Okay. Under certain circumstances, a normal distribution curve can drop below the x-axis. False.
Right.
Okay.
A normal distribution curve is symmetrical. True.
True.
Use the following image to answer the next 2 questions. Which of the following elements of the figure represents the z-score?
It would be C, right?
Yeah. And then which of the following elements of the figure represent the probability that the z-score will be greater than 1? Would that be B?
E.
Okay.
Yeah.
But A is, you see that the picture, A is pointing to both sides.
Yeah.
Mm-hmm. That's at 1 or below, right?
Yeah.
Yeah.
But greater.
It says greater, yes?
Yeah.
Okay. B.
Question 8. According to the 6895 rule, what percentage of the data will form from a bell-shaped distribution will be within 1 standard deviation of the mean? So wouldn't that just be 68?
68.
Isn't that what it was? Yeah.
What percentage?
We have 0.68.
Well, it says write your answer as a percentage such as 42 rather than a proportion.
Yeah. Okay, 68.
Yep.
68% or 68, right?
Yep. I
Okay.
think so.
Okay.
Suppose that.
Go ahead.
Sorry, yes, just to write correctly. In the parentheses said write your answer as percentage. Yeah, but I don't have to put the sign, no?
No, you just put 68, no decimal or
Yeah,
no.
not a number, no? Yeah, only the number.
Yes.
Use the normal probability applet to answer the question. What proportion of the z-scores will be between -1 and 1? So you just plug that in and then 0.683.
Why is it giving me a hard-
600, 68.
Yeah, but this you would write with the decimal with 3 points, so 0.683. About what you guys are getting.
Okay, sorry. What were we supposed to type in?
You just put z-score as 1.
Oh, z-score. Okay.
And then you just select the middle section because you just want to know what's between them.
0.6827. So we're going to round it off just to 0.683, right?
Yep.
Okay.
And then it comes from a standard
Oh,
between
18 questions.
Oh.
so,
We're getting there. We're more than halfway there.
but then you just plug in 2 as the 1, and then between it comes up as 9.955.
5.
4.
5. No, 5.
Yep, you're right.
545.
9.55 is.
0.95.
Yeah, it's easy.
Oh, so he said
now.
95955. Okay.
Yeah.
Okay, got it.
Okay.
Number 11, 0.997.
0.997, yeah.
Looking for the answers to the last questions.
Oh, it's values match the 68, 95, 97.
Yes.
Oh, yeah. Okay.
Yes, you have to mark. I don't understand the question there, number 12. I know that the first one is right.
Yeah, that's what we observe. The other two, we don't see them, so it's just the first one.
Yeah. Okay.
Oh, no. This is a long question.
Okay. La parte de la individual más considerada for a person the word solitary plus ideas of normally in relations in the United States everyone is given to person.
So we see the mean is 0.65.
Yeah.
And the standard deviation is 0.07.
0.07, yes.
So then that is less than 0.60 grams.
Yeah.
So do we try to find the z-score of 0.60? I think that's what it is.
Less than 0.60.
So in our applet, we put in 0.65. The population. Oh, no, we're doing the mean score. Okay. Mean 65. We have negative 0.71.
7.1, yes.
Yeah, but is that the answer, or do we then plug that into the applet and less than 60? I'm just.
What portion of population have requirement less than 60?
I don't know where we go from there. I don't know if that's all we go. Do we just find the z-score and are we done, or what?
Right, we have if we put 0.
saying. I think we have to put in the applet because the next question asks what is more than 60.
Yeah.
Yeah, I think we're gonna put so negative
Negative
1,
714.
714. So less than 60%, which is our
Would be
Mm,
0.2376. 238, right? 0.238.
What is that? Would that be the 60% of just that one? I don't know what.
What portion of the population have a protein requirement less than 60%?
Yeah, I got my applet. I think it's 67.6. Let me show my screen.
Yeah, show your screen.
Yeah. I put 0, city score 714, and just select under that, no?
Because 60% would be I think that's right because at 0 we would be at 50%, right?
Yeah, but in those ones we saw, the first line represented, like 1, below 1, or above 1, or between. So I don't. Is it just the first area?
I think that it's this area I mark or not, because the question is what proportion of the population have a protein requirement that is less than 60, no, 0.6.
0.60%.
But the mean is 0.65, so it wouldn't go over the mean, and the mean's in the middle, right?
The mean's in the middle because we're using the 60.
Okay, yeah. So it's going to be without this?
I have no clue. I don't.
We did something wrong here. Yeah, we are clear that CITES score is 714, no?
Yeah.
Isn't it?
I agree with that.
Yeah.
I agree with that, but then I just don't know.
Well, we have to do the next question is so it's either it's going to be less than 60% and then over 60%.
No, but it's not percent.
Oh no, it's not percent. It's 60.
It's not percent. It's the quantity of protein.
Oh, the mean is 65.
The mean is 65, but it's not reasonable, no? The answer.
Is
because here, as I see in the applet, if I put this code for 60 proteins, I got this area. But as you say, Brina, it's over the mean.
Yeah, I'm not sure.
Because the mean's here, I think.
Our z-score is so our z-score is still in grams, though, right? So we're saying our z-score is 714. So
we did something wrong with that zero.
We found the z-score for 0.6. I think we're thinking too much into this, but now we can't find our way back.
Yeah,
so many more difficult questions. We're thinking on that level, and we can't find our.
Yeah, my first inclination is to say that it is going to be in the bottom part of the bell, the first bell. Yeah.
So, what do you think is going to be the answer?
I do not know.
I was thinking it's to the left.
The left.
The left two or just the left one?
23?
23.20.
What's the area in between the two?
So area, okay, hold on, let me get this.
52?
So
All right. Well, I know this is a really bad time to leave, but I really have to get to work.
yeah, you know, I think
I'll just leave my quiz open and then maybe I can watch the rest of the video with you guys talking about it or email you guys or something or see.
yeah, because we only get one shot on the quiz,
Yeah.
and I think that we're towards the end of the quiz anyways.
Yeah,
So,
and I can keep it open as long as it's unlimited time, so I can keep it open while I'm at work and then I'll do it after work. But
Marianne,
it was nice talking to you guys.
good talking to you too. We'll see you later.
Thank
I'll see you later.
Bye. Sorry,
you.
so long. Okay.
Yeah.
So
It's
Mariana, we have just these last 6 questions.
Yeah.
I'm going to look back at the lesson for a second before we answer that.
Okay. I will check also.
Okay. And the back question is,
It looks that this having sense, no?
what was that?
It looks like if this doesn't have sense, the answer doesn't have sense.
Yeah, so we know that 60% is less than the mean because the mean is 65.
Mm-hmm.
Here.
Unless that we just need to mark this part. So,
Yeah.
yeah.
Yes. Wait, hold on. Let me see what you're saying. Which one?
Yeah, I think that you have to answer here because maybe here is 60, no?
Yeah,
And that is 23.76.
that's what I was thinking too, because the mean is in the middle.
Yeah, that means in the middle, yes.
Yeah.
Yeah. So you have to put in decimals, 3 decimals, no?
Let me see.
23, 8.
0.376. So, yeah.
8.
0.238. And so the next one is going to be
a consequence of this.
more than 60. So that's going to be the middle part of our distribution bell.
Yeah, it's
Actually going to be it's going to be the left and the middle. So that's 0.762.
2, yes. Yes. And we need number 15, we need to calculate again.
So a portion of the population requirement is less than 70 kg or 70 grams. So we know that our
it got the same zero, but it's positive.
Portion of the population is less than 70
The same theta.
This is so many numbers, so many letters. Um,
I think that it's 0.762.
let me see how you calculated that.
Could you see my screen?
Yeah.
Yeah. Because I put in the Excel number 7.7 less the mean under deviation, no? And we got the same theta.
Oh.
But positive.
Minus the mean. 0.7.
But positive.
Divided by the
standard deviation.
0.07. 0.74.
Yeah, and we got the same theta score. 0.714.
Should we have done that with each of these other ones too?
Sorry?
Should we, what portion of the population? Oh, I see. So
here is 70, 0.70.
Wait, let me see yours again. Now I'm getting confused. So 714 is 7.624. Oh, wait a minute. Let me go back to this because it's not asking us the probability of this question, right? What portion of the population have a protein requirement less than 0.7? So that answer is 0.714, right?
0.762. It's not the area?
Yeah, let me read the question one more time because now let me just think about this for a second.
Okay.
The amount of protein that individual must consume. Protein requirements are here. What portion of the population, normal probability, have a protein requirement less than 60? So it's saying what portion of the population,
Because in number 12, we answer with decimals without thinking in percentage.
Portion.
Number 13, 14.
Okay, remove this from the portion of the population of data. So of 2.8. Okay. So if we take okay. I see that. So we go to the applet to find the portion of the population. You know, I almost feel like if we could plug it into this quantitative description, we could see the bell curve a little bit better.
Yeah, I understand better now because here we have 2 points, no?
Yeah.
Two red points, no? This one is 70 and this one is 60. And the mean is 65.
Yeah, okay. That's so the answer then for number
18?
18 is going to be 0.762, right?
18. What number are you?
14, right?
We are 14. You're 14.
Wait, because didn't we have 0.762 for number 14 as well?
Yes, yes. And 15 is the same.
Okay, 0.
Yeah.
2. Okay. All right. And then, all right, we're going to just go on to number 16.
Yeah, number 16, yes.
We won't know. I mean, we won't know if we get these right or wrong if we just get stuck on it. Okay.
Yeah.
So find the probability that a randomly selected person will have protein requirement that is between 0.6 and 0.7. Remember to find the area between the two values. Shade to the left of each z-score you calculate, then subtract the smaller area from a large area. Make sure your answer is positive.
Yeah, I think you see my screen.
So, but did we calculate because it's 0.6, right? And then we take the minus 0.65. Is that right?
Yeah, but it's the same because we have now the value. Here is 60 and here is 70. And the area will be 0.525.
Okay, let me 60. Okay, let me quickly do this, and then just so I can get it out of my head. Nice. 0.07. So, and then you have 714. The middle part between 70 and 2. But hold on, let me see. 0.7 minus 0.65 divided by 0.07 is 0.7 minus equals divided by equals 0.714. Same thing. Okay, this is negative. That's positive. Okay, I agree. So it's going to be 0.525.
Yeah.
Yeah. Okay. That's number 60.
Oh my God. Yeah.
I need to find the area available to shade left of each z-score you calculate, then subtract the smaller area from the larger area. Shade left of each z-score, and then subtract the smaller area. Oh no, it's actually so shade left is 0.2376.
Good.
And then shade right is 0.4752, smaller area from the larger area. Let me see. Remember to find between the two values.
What's the deviation?
0.4752 minus 0.2376. No, I'm going to just, we'll just do that question. I'm so confused.
Yeah, I think it's in this way. You can look my screen.
Okay. Okay.
Yeah. I figured with the pamphlet. We got the area, yes? That it's 45, it's right?
Which one are you on? Are you on the
17?
Okay. I think 35 and then 0.35. I got to read that one. I didn't read it yet. Let me see. Find the 35 percentile for the protein requirement. for adults. Round your answer to 3 decimal points.
Yeah, so I write here, I wrote here 35%.
Mm-hmm.
And I have the CT score that is 385.
Mm-hmm.
And I put here in my Excel a deviation,
Mm-hmm.
0.07 by the CT score.
Mm-hmm.
And I got this number, the 0.02695. I have to add, I mean, so the answer will be
6, 7. So 35 percentile is going to be
your answers.
I think
But it's negative, no?
baseball averages, finding probability, percentiles and distributions. Okay.
No, I don't get confused here.
Okay, let's do it this way. So we're saying that 35 percentile gives you 0.385, right?
I don't understand this part of the percentile. For example, in this pamphlet, sorry, this side is a 13 or this side?
Well, you're just looking for the z-score, right? So the z-score is 0.385.
Yeah, but is this side or this one?
No, it's just the at 35%. The z-score itself is 3. So you still have to do the calculation.
No, but yeah, it's right. I mean that when I talk about the percentile in the 17 question, we were asking about 35 percentile. It means that it's going to be from this red line to this one, or from this red line to this side. I think it's the left.
I'm looking at I'm looking at the back at the lesson where it says calculating percentiles using normal distribution. So when you put the 35%, it gives you a z-score of 0.385, right? So now we know our z-score is 0.385. So we have to go and solve for x on that. So so if we go back to the quiz here. So we know that the answer, let's see, the result is
but the answer is going to be different because on the left we got a minus the score, and on the right a positive. So our answer will depend and is on the left or right, because we have to add the multiplication to this by the deviation, and we have to add the mean. But if it's negative, the answer is going to change.
Yeah, I think we have to take the 35 percentile. What is the other? 80 percentile. And then, so let me just look at it for a second. Because 35 percentile is that over 7. So that's going to be 0.385 times 0.07 equals 0.026. It was at a negative. That's a negative 385, huh?
Negative.
Yeah.
Yeah. So the answer is going to be 0.623.
0.26. It's going to be 0.54, right? Or no, I'm sorry, 0.57 is for the 60, and then for the 70, it's going to be 70 is 50. 7. 0.70 minus 0.026 is 0.674. And so, let's see, for the 30%, round your answer. So,
yeah, I think it's going to be 0.623.
0.623. Yeah, I'm really confused. Okay. Let me see your answer. Let me see how you got it again.
Yes, yes. Yeah. Here, you can see, or it's too little?
No, I can see. So,
yeah, I got the deviation, but it's minus. Sorry, the deviation is positive. What is minus is the z-score. That it's minus 0.385. I multiply that and I got this number 0.027. And I need to add this to the mean. How this is negative, I'm going to have less than the mean. No? And it's going to be 0.623.
Because we did it in the homework, because this question, I'm trying to see if this question is comparable to a question that we had in our homework. So, because this question is similar to 7,
like
right?
7.
It's like 7F, right? That's similar to that one.
Yes, yes, similar to that one, yes.
And when we found that answer, what was the formula that we used again for that?
Yeah, the same that I'm using now.
Okay.
I use this. I will do it again. That's 7.
Okay. Yeah, let's do that. Yeah, I'm going to write this out.
The mean is 1,000.
F.
The deviation is 600. But here in the applet, we put
75%, right?
And we got this z-score. That's how we got the answer.
The standard deviation. Was it multiply?
Yeah, the standard deviation. Multiplying by the
z-score, right?
And then we add this to the mean.
And then you add, and then add to the mean.
Yes, and it's 2,204.
So this was our standard deviation. Okay. All right. So then you're following that. We're taking the standard deviation of 0.385, right?
Yes.
and we're multiplying that by the z-score.
Mm-hmm.
Oh, no, I'm sorry, 0.707 multiplied by 0.385, right? And then adding it to our mean, which is 0.65.
Mm-hmm.
And then you have oh, my answer comes out a little bit wrong.
Yeah, because you have to consider the z-score minus.
Oh, okay. So it's okay. So I see. So minus in that, okay, so it's 0.623. Okay, I agree. Okay. Sorry, Mariella, it takes me a while.
Yeah, I was. No, don't worry. I have the same problem in the other cases.
Oh, wait, I didn't, and then, oh, I didn't save my 16. Okay. And then, so now we're in question 18, right?
Yes, it's going to.
So 80th percentile, so we have to put in, is it 0.8 that we put in the top or 0.2? It's 0.8, right? So our z-score is 0.842. Is that right?
Yeah, 0.842. I got the same.
Okay, and then we multiply our standard deviation. That's a positive, right?
Yeah, it's positive. Yes. Uh-huh.
Okay, and then plus our mean. Do you have 0.708
Yes.
or that's
0.9.
uh
9.
0.7? Wait, let me see your answer. See if it's yes. That's what I have.
Yeah, we have to round to 3 decimals. So
Okay,
0.09.
0.9.
Yes.
Okay. Can we go through our answers one more time before we submit?
Yes, you need to review it.
Yeah, let's review. So starting for 1, completed the individual. For we couldn't complete it. That's why we had to do it together.
Yeah.
So I put true, actively true. Okay. So total area and a normal distribution curve must equal to 1. Number 4 is false.
False.
Number 5 is true.
True. Yes.
Number 6 we said was going to be C. Number 7 is B.
Yes.
And number 8,
68.
yes. Oh, 68. Number 9 is 0.683. We said standard normal distribution between 1 and 0. Let's check that one more time. So 1 is, ooh.
Están presentándose a las 8, 9 de la noche.
Yeah, 6.683. Number 10
is 0.955.
Yeah, that's what I have. And then number 11 is, change that to a 3. 0.9973, right? 0.997.
Yeah.
And then for the next one, the values match is 68, 95, 90.
Much. Okay.
but also the z-scores increase too, huh? Is that true too?
Increases. As you said, the score increases.
No, we'll just stick with the first one.
Yeah, the first one, yes.
But as the z-score increases, the area between negative z and negative decreases. No, that's not true. It gets bigger. Okay. All right. So the first one is the right answer. Then this is where I was getting really confused, but I think we're okay, huh?
Number 12, you're
Number 13.
14, yes.
The amount of
Yes. Yeah, but I'm sure about the answer now.
okay, the population protein for requirements for adults is 65. Population standard deviation is 0.07. What portion of the population have a protein requirement that is less than? So we figured out that the z-score was
erase that, but I will do it again.
oh, do we have the portion of the population?
It's the theta is 714.
That's right, 0714. That was the negative 0714, right? And so we said,
yeah, less than is the area. It's 23.8. It's right.
okay. All right. And then the next one is what portion of the population have a protein requirement more than, we said 0.762.
Yeah. Is the other side.
Right. Okay. It's both. So it's both the low part and the middle part, right? Okay. So it's 0.762. And then number 16, this is the one we just did with, I think this one is okay.
Yeah.
0.525, and then number 17, 0.623, and then 0.709 for number 18, right? Okay, I'm biting my fingernails. Now we have to submit. Are you ready?
Crossing fingers.
Go ahead and submit.
What's happening? Yeah. Okay.
100%!
Yes.
Yeah. Oh my gosh. Okay, now we just have to keep practicing. Good job.
But we have clear many things now. I think by myself, I understand better about the percentage, because with the percentage I get confused. Less, more, less, more. I think it's
More,
for me. Yeah, it's for me. It's like when I confuse with left and right.
Right. Well, I'm